Hello and welcome back to this video series where we're looking at building an e-commerce platform in 25 days using Next, Netlify, and Stripe. So in this video, we're going to look at how we can request data from an external API and bring it into our Next.js application. For this video, we're going to be doing everything client-side, so similar to how you would do in a regular React application. But in future videos, we're going to look at static site generation and some things that Next actually gives us that makes this much more efficient. But in this video, we're just going to work through the concept of requesting data from an external API. So the external API that we're going to be using is going to be this Pokey API, which is an awesome project that someone has made. You can read more about it on GitHub here, and I recommend you do, and go give them a star. This is an awesome open free API that we can send a request to and get back a collection of Pokemon. So if we scroll down, you can see that there is just this base URL, and then if we go to that base URL /Pokemon, we can get back a collection of Pokemon. So let's go do that in code. So if you followed along with the previous video about preview deploys in Next.js, then you'll probably still be on this products page branch. And you can check that by typing git branch, because your terminal probably won't look like mine. So here you can see which branch you're on. So I'm currently on the products page branch, but I want to be on the master branch. So I can change that by saying git checkout master. And then because we opened a pull request in the previous video and then we merged that into master, our GitHub now has an extra, it has our products page included in it, whereas our local master does not. And so all we need to do is, before we write any new code, we are just going to git pull from origin master. And this is going to pull down any changes that we might have there. So the first thing I'm going to do is install a library called Axios. So we don't actually need Axios to be able to make a request to this API. You can use the built-in fetch API, but I just find Axios is a little bit easier to understand and comprehend, especially for educational videos. So we're going to use it for this. So now that that's installed, we can open up VS Code, and we're going to create a new component that we're going to use to make a client-side request to get these Pokemon. So I'm going to call it client-side.js. So now if we run our Next server, we should be able to navigate to /client-side and see our new page. Awesome. So now let's make a request to the Pokemon API. So first we're going to bring in Axios. We're also going to bring in useState and useEffect from React. We're then going to call useEffect inside our component. And inside here is where we're going to actually make a request to the Pokemon API. Before we do that, we're just going to make sure we pass an empty dependency array. Otherwise, this might make a lot of API requests very, very quickly. And so we're just going to make sure we have that empty dependency array, so it's only going to make this request once when we mount our component. Okay, so the way that we make a request to an external API with Axios is we say axios.get, and then we give it a URL. And what this is going to give us back is called a promise. And so in JavaScript, a promise is what we use anytime we want to execute some kind of asynchronous code. So in this case, we don't know how long it's going to take to send that request off to the Pokey API and get our Pokemon back. We don't know whether there's going to be a lot of load on the Pokey API. So it might take 1 second to resolve. It might take 20 seconds to resolve. We don't know how long that's going to take. So we get back a promise, and then we can await that promise. And anytime we use this await keyword in JavaScript, we need to wrap that in a function that is an asynchronous function. So the way we do that is inside this useEffect, we're going to create a new function called fetch Pokemon. And that's going to be an arrow function. But the way that we make that an asynchronous arrow function is we put the word async in front of the parameters. And then if we just move our axios.get statement in there, and then we want to have a look at what we actually get back. So let's have a look at the response that we get back from when that promise resolves. And then let's console log out what that response is. We're also going to need this URL. So I've copied it from the Pokemon API, but you can head back to that website if you need it. And now we're going to save and have a look in our application. Okay, so nothing has shown up in our console. If we have a look back at our code, that's because we declared a function here. So we created a new function called fetch Pokemon, but we never actually called it. So underneath that function, we are going to call get Pokemon. And now if we have a look in our application, we see this big object that has a whole bunch of config and headers and a whole bunch of information about the response that we got back. But we really only care about this data part here. So we've got data, and inside data, we have results, and that is a big list of Pokemon. So you'll see that each Pokemon has a name and then a URL, which we can use to get more information. So if we wanted to access the URLs that are going to give us more information about each Pokemon, we would need to do that by going from the response level. We'd need to go response.data.results. So that's going to be a big array of all of our Pokemon. So we could iterate over that array, and then for each index within that array, we could access the URL. So let's do that now. So remember, it was response.data.results gives us our array. And then we are going to do a for each loop over that array. And for each of the results, for each result, we want to console log out result.url. So let's just comment out that first response. So we should just see a list of all the URLs in the console. And that looks right. It looks like we have the URL for Pokemon 1 all the way through to Pokemon 20. So this is giving us the first 20 Pokemon. And so what if we wanted to list out all 151 Pokemon? And before you get started, there aren't more than 151. Red, blue, yellow, these are the only real games. So 151 is all we care about. So to extend the number of results that we get back from the Pokemon API, we can add on a query parameter. And so we are going to say that we want to set the limit to 151. And so this, if we save and go back to our console, is going to give us the first 151 Pokemon. So the URL to get more information for Pokemon 1 all the way through to 151. Okay, so the page that I want to build out in this video is going to be a collection of all 151 Pokemon with their name and then an image of each Pokemon. So it's just going to be a list of their names and the corresponding image. But right now we don't have enough information for that. We only have the name and the URL to get more data. So if I click on one of these URLs to get more information, so if we look at more information for Mew, you'll see that we get not just a name and a URL, but we can see the ID for Mew, we can see different moves that Mew has, height, weight, but the bit that we really care about is under sprites, we have this front default. And so if we click this, we will get an image of Mew. And so in our application, once we get back this list of URLs, we essentially want to iterate over every single one, make a new request to that URL to get the more information about that particular Pokemon, and then dig into the sprites and the image and get the image for each one of those Pokemon and then display it on our page. So let's have a look at how we would do that in JavaScript land. Okay, so we've already made a request for those 151 Pokemon. We've then got that URL that we can go to for each one. So then we're iterating over each one of those results. And then this result.url is really what we want to make an additional request to get the information for that particular Pokemon. And so we're going to want to say Axios.get and go and get the more information for each one of those Pokemon. So again, Axios.get is going to give us back a promise. And so we could build up an array of promises. So we can have const promise equals an empty array. And then in here we can say promises dot push, which is going to add a new element to that array. So we're going to push in each one of these promises that this is going to give us back. And then we need a way to wait for all of those promises to resolve. And so the way we can do that is we can say Promise.all, which is a function that takes an array of promises, and then we can await for all of those promises to resolve, and then we will have our responses. So now if we console log out our responses, we should see this array of 151 Pokemon, but then inside that, we have these objects that have data, and then inside that data, we have that extra information that we were looking for. So this one is for Bulbasaur, and then if we were to look at the next index of that array, this would be Ivysaur, and then what's the next one going to be? Is it going to be Venusaur? It is. Okay, cool. So we're getting that extra information for each one of our Pokemon, but we're also getting a whole bunch of extra stuff. Like we don't really care about abilities or forms or anything like that. So we probably want to kind of like filter this list down to just being maybe a name and that actual image that we care about. Okay, so we're going to take those responses and we're going to map over each one of those responses, and then we're going to do something. So a map is very similar to a for each loop in JavaScript. They're both going to iterate over each element within a collection and call this callback on every single element. The difference is that map will give us back a new array that contains whatever we've returned from each index. So each of these, whatever we return will kind of take the place of that element within the array. And so we get back an array of, let's say, Pokedata. And Pokedata is going to be an array of whatever bits of information we decide to return from here. So since this for each was really being used to construct a new array of all of these promises, we could easily refactor this as a map by replacing for each with a map. And then remember, map returns something. So we can get rid of this bit of code. So whatever we return, we want to be the new variable promises. So this is going to be our new array. And then rather than pushing into promises, we simply return that Axios.get. So anytime you find yourself creating an empty array outside a for each loop and then kind of pushing something into that array, that's probably a pretty big hint that you can refactor that as a map. Or just use a for each if you prefer using them. Maps are used pretty frequently throughout React, so I just thought it would be a good idea to cover the difference here. Okay, that was a big detour. What were we actually trying to do? And so if we go back to our app, we are going to be iterating over this big collection of Pokemon, and then we want to dig into data and then dig into sprites and grab the front default. And we're also going to pluck out the name. And so the only thing we really care about is the name and that image, so that front default image. So that's what we're going to return from our map. So we're going to return a name, and that's going to be set to r.data.name. And then we were also going to return an image URL, and so that's going to be r.data.sprites.frontDefault, I think it was. And let's just console log out our Pokedata to see what we have back. I'm also just going to get rid of this console log and the commented out console log up here. Okay, so we get back 151 results, and if we dig into those, we've got these objects, but now the objects just have a name, Bulbasaur, and then an image URL. And again, if we click on that, we see our image of Bulbasaur. And then if we scroll down, look at Magnemite, and click on that one, we get Magnemite. Cool, so we've filtered down our gigantic collection of extra data just down to the bits that we care about by using this map. And so we've mapped over each result, and then we've just plucked out the name and image URL that we actually care about. Okay, so if we actually want to display this on the page, we probably want a variable to store that in. And so again, we're going to use state, and we're going to give it the default value of just an empty array, and that's going to give us back a Pokemon variable and a set Pokemon function. So now once we've filtered down our results to just the bits that we care about, we're going to call set Pokemon, and we're going to pass it that Pokedata. So now I can get rid of that console log, and if we, just before we return, if we console log out what our Pokemon variable is set to, we should see that set to an empty array to begin with when it first makes that request to go off and get the Pokemon, and then we get back our results and it swaps that out. So we could just iterate over our Pokemon here. So we could say Pokemon.map, and then for each Poke, we want to return a div, and inside that div, we want an image, and the source of that image is going to be set to Poke dot image URL, and so that's just what we set as the parameter or the property key here. And then we also want to print out the name. So we're going to have a paragraph tag, and we're going to put Poke dot name. And again, that name is going to match what we returned from that map. And just to give us a little bit of visual help, we're going to add a horizontal line underneath each Pokemon. Okay, so if we go back to our app, we should see Bulbasaur and Ivysaur and all of this. We have a warning here, and so React is telling us that each child in a list should have a unique key prop. And so this is just something that React uses under the hood to determine which element within a collection it's rendering. And so we just need to give our outer div a key prop and give it a unique value. So here I'm just going to make it Poke.name because we know that each Pokemon's name is going to be unique. And if we refresh, that should get rid of that warning. And again, we just have our empty collection. And then when we get back our results, it swaps out these Pokemon. Okay, so that looks like it's going and grabbing those results really, really quickly, right? Like we only see a flash for a second, and then we see Bulbasaur, and we see the rest of our Pokemon. But if we have a look at the network tab, each time we make one of these requests, you'll see we're getting back a 304. And so this is actually coming from our cache. If I have a look here, we've got X cache hit. And so this is, our browser is actually caching the result from our API request, and it's just giving us back that cached version every single time. So this might be fine for something like Pokemon that don't change very often. Like there's only 151 Pokemon, and that's all the Pokemon that have ever been created, so that's fine. But in the next few videos, we're going to be building up products, and so we probably want our product price to be able to change pretty frequently. We might want to add new products. And so we probably don't want to cache those results and just get back the same results every single time. We probably want to make a fresh request to the API. So we can actually turn off that caching that's been put in place by the Poke API by passing across an additional header. So what this cache control no cache header is saying is, I know caching is a great idea and it's really efficient and all of that, but we're trying to teach something here, and so we want to see what it would really be like in the real world if we made a request to an API. And so we just want to switch off caching for this request. And so we can, anywhere where we're doing Axios.get, we can pass it an object of options and pass across those headers. Okay, cool. So now if we head back to our browser and refresh, we'll see a much more realistic version of these requests being made to the server. So you see that took a significantly longer amount of time to actually go and get the results. And that's because we're getting the 151 Pokemon, and then we're iterating over every single one and making another request to the API for the data of ID 1, and then another request to the API for the data for ID 2. And we're doing that all the way to 151. And so again, if I refresh, we'll see that that takes a really long time to go and get all of those results and put them together and display them on the page. So in the next video, we're going to look at something that Next gives us called static site generation, which is going to make this much more performant. I'll see you there.